Hello. So in this example right here, I'm demonstrating what it would be like to use the NodePort right here. And for the token server, as you can see, what's kind of neat, after I applied the NodePort change, AWS behind the scenes went ahead and automatically removed, I should say, COPS. It automatically instructed AWS behind the scenes to remove the additional load balancer that we had for the token server. As you can see, we're back to 1 right now. So the change I made was I just went into the service and changed this type from a load balancer to a node port right there, and just did another apply on it. So as you can see, basically our endpoint now with the node port is it's going to expose the, shall we say, the port in the container using this external port, which is, I think, like 31181. So not really something I would recommend doing right here, but basically I just kind of wanted to go right up here, and what we can do is actually just get the EC2 instances right here. So we could say kubectl get nodes. Basically, we've got our IP addresses. We'll just take one of these particular nodes. Okay, and let's see what happens. I'm just kind of toying around here, but let's see what happens when we visit that with port 31181. Let's see. So as you can see, that's not exposed. And the reason it's not, the reason in that case is because I just did something stupid. So as you can see right there, our IP address is not exposed. So as you can see, I'm just kind of, as they say in the industry, I'm fishing here, just to kind of show you different things that could potentially happen and or go wrong. So now if I were to take one of these particular nodes, and here's our, again, we've got our public IP address for this one right here. So really what we want in this case, we are not seeing anything come up there. So just kind of playing around with commands. Next thing we want to do is we want to say kubectl describe service. And let's take a look at our node token server. So here's our IP right there, our endpoints. Okay, so now what if we go back to our 2 instances? Since the IP didn't work, what if we go ahead and copy that, which is the public DNS right here? And what if we try to access port like 31181 directly? Well, it's going to spin. So that always usually tells me potentially that it's a security groups issue in AWS. And again, 31181, that particular port, that is which we've got going right here with our kubectl get service. When we expose our node port in the cluster, this is the port that gets exposed, and the traffic is being rerouted to port 5000 in the container within, or the pod, well, actually the service within the Kubernetes cluster, which is the service is taking that port 5000 and redirecting it to the pods themselves. And so now what we need to do is, let's go to our security groups for that instance, and we're going to go ahead and add another rule, and we'll just say like port 30,000 to, we can open up a bunch of ports, but just remember we've got some ports being opened up. Actually, we can just open up the port that we want. In this particular case, 31181, what happens if we open that up? 31181. And let's go ahead and just allow all right here. Now, if I refresh this again, as you can see, we've got our token server up and running. Now I'm going to go and take this URL, this big big nasty domain name. And I am going to go ahead and update some of our deployments here. So I'm going to say identity. Okay, so we want cart deployment, and we want order deployment, and we want web MVC deployment. And we want to update all three of those. And I'm just going to go ahead and save this right here. And I'm going to do this for the other two files. So, oops, don't want to put HTTP in there twice. I'm going to go ahead and do this to the other two files, so you don't have to watch me do that. I'm going to pause the video. Okay, so I just applied those. So I made that change in there, and I went ahead and applied those pods. And so what we've got going here, let's go ahead and give this another whirl. Okay, so we'll say www.tvcosec.com. There we go. So let's do the login screen. Okay, as you can see, we are now redirecting to, if you look closely right here, we are redirecting to the exposed, shall we say, pod or the service. It's actually redirecting traffic to the pod, which is fronting the identity server there. And let's just say never here. But as you can see, we are now logged into the application right here. So let's just make sure I got everything else tested appropriately. So I was able to add that record to the cart. I can do an update of a quantity. We'll just update it to 12. Make sure that we can save our orders and pay and place an order. There we go. Your order is complete. And as you can see, we can log into my orders here. It's looking pretty good. So what is the difference right here? What did I do differently here than I did in my last demo? Well, in my last demo, I fronted, basically by using the type load balancer for the identity server. It's kind of a subtle change, but in our token server, for example, actually it's our service, not deployment. In my last example, what I had was I had a type of load balancer, and that's all fine and dandy because you can put certificates right at you can SSL terminate at the load balancer level. Just keep in mind with that case, AWS, is going to go ahead and create another load balancer for that. In some cases, it's good. Other cases, may cost you a little bit more money. In this case, so instead of seeing the two load balancers running now, we just only see one. This is for the actual Kubernetes master, so you're always going to get that load balancer right there. But basically, this one right here is for our main web app, which we want as a load balancer. We could have NodePorted that as well, or put that behind an Ingress controller. But now, instead of two load balancers, one for the main web app and one for the identity server, you see just only one load balancer. And now we're still able to log in and and basically perform identity and things of that nature. And only this time, if we do get service, only this time you can see the token server is running in the cluster with an exposed port of 31181. We did have to go and change our security group to open that up. But basically, we're able to do this same exact example without having to use a load balancer for the token server. And again, in the real world, the best way to do this would be to use the Kubernetes Ingress controller type, which I have a video previously where I got that up and running. And then you could SSL terminate that. In that case, it was using certificates from Let's Encrypt instead of using the ACM. And the ACM for AWS is perfect if you've registered a domain name and transferred it to AWS, or if you've actually registered the domain name through AWS, as I have. And in that case, you can just use the ACM right there to SSL terminate your load balancer. So I hope this demonstration helps a little bit too, on just how you can kind of do things a little bit differently. So again, thanks for watching, and don't forget to tear your cluster down. That's another disclaimer for if you're running this in whatever cloud platform you're running. You don't want to keep this running because you will incur charges, and so can't stress that enough. And the other thing is, don't forget to buy this particular course if you like what you saw, and because he will teach you an awful lot. So thanks again for watching. Bye bye.